I'm Pete Border, and welcome to the Physics 1108 Labs. What we're going to do in these videos is work through all the labs so you can see how they're done. If you have any questions, feel free to email me. That's fine too, but this is just to give you an idea of what this stuff looks like when it all works and how it all fits together. Now, in the first lab, what we're going to do is investigate what heat does in various substances. And to do that, we will eventually getting around to heating up substances of different materials and putting them into a known quantity of water and seeing how much the water heats up. That will allow us to measure the amount of heat energy in the materials because we know how much energy it takes to heat up water by a certain amount. What we're going to do first right now is demonstrate how to get a prepared sample of cold water. The idea here is to get some water, 1 cup's worth, at a known temperature, 0 Celsius, and then we can do experiments with it. So to do that, first we take our cup that we have pre-chilled. I put some ice and water in here just purely so we start with a cold cup. You don't have to measure how much goes in there very precisely. Just fill it up and let it cool down. The thermometer is also pre-chilling in here. It's cooling down too, sitting in the same ice and water. To get our controlled amount of water in here, what I'm going to do is pour out the ice and water in here and then fill it up with a known amount of cold iced water from this. Now, the amount of water that I pour in here, I do want to measure. I want to have as near as I can get to 1 cup's worth of cold water with no ice in it. So that's the whole point of what we're doing here. We're pre-chilling our little cup, pre-chilling the thermometer, putting in 1 cup's worth of cold water with no ice. And that's what we're trying to do. All right. Now, with these things, you have to move fast because heat flows in all the time. Things warm up pretty quickly. So I'm just going to go through this and move as quickly as I can. Here we go. First, this comes out. That goes away. All the ice comes out. Then I use a fork to strain ice out of here. So I only get water. And I pour my chilled water in until I have 1 cup's worth. And I put a little mark on the inside of the thing so I can see when I have 1 cup's worth. Put the lid on, put the thermometer through a hole in the bottom, and start my timer, like so. And the initial reading on here is about 0.8 C. I'm going to keep track of the reading for the next half hour, reading it every 2 minutes. This is purely to see how much heat leaks into this equipment as we are letting it sit so we can subtract that heat later. Okay, what we're going to do now is use one of these cold water samples and measure how much heat comes out of a sample of a different material at a higher temperature. So what we will be doing is taking this sample. This is steel. The steel wire in my kit anyway was quite a bit larger and it wouldn't fit in the container here, so I rolled some off and cut it down to get it into a size that would fit in here easily. and you're going to have to do the same thing. So prepare a cold water sample, just like the one we just did. And now we're going to take some hot water. This water has been boiling in a kettle. It is at 100 degrees Celsius. I'm going to fill up a nice big coffee cup with that. The steel is sitting in the cup. So the steel is now warming up and will be at 100 degrees Celsius shortly. Meanwhile, we can just wait. We're all set. So, okay, by this point, the steel is probably hot enough. Notice I left a little handle on it so I can pick it up safely. And I lift the lid on here, drop the hot steel in, put the lid back on, squish it on so it fits tightly, and watch what the temperature does. And the temperature should start climbing. You should get several degrees worth of temperature climb out of about 40, 50 grams worth of steel. The water temperature is much harder to raise than the steel temperature is to cool. So even though the steel is coming down from 100 degrees Celsius and the water is going up from 0, you wind up with a final temperature of 5 or 6 degrees Celsius. It's really not much of a change. Okay, so now we sit here and you take temperatures, write them down every 30 seconds for 2 minutes, and we'll come back when we've got that done. All right. Okay, in this one, we are going to add heat to cold water again, except this time we're going to be adding a known amount of heat to a water sample by using electricity to do it and a battery. And this way we can measure how much the water heats up with a known amount of heat going into it. There are some new things in your lab kit that you're going to have to use for this one. First off, you should have 2 big batteries like this, the old Rayovac 6-volt batteries. You should also have a couple of wires with clips on them. They're in a bag in your kit, but you can get them out. It's good to have different colors. It just makes them easy to keep track of. And you're going to need a resistor. Now, a resistor is an electrical component. You should have a bag like this one with several different types of resistors in it. The one you want for this experiment is a 10 ohm resistor. And ohms are one way to measure resistors. The resistors all have labels on them. Here's the 10 ohm one. You should have 2 of these in your kit. They're kind of small. They have a piece of paper on one end that says 10. The others in the kit say 1,000 or 86 or something like that. You want the 2 10 ohm resistors. And what we're going to do is make an electrical heater out of the resistor, the wires, and the battery. And we're going to put that into the water and measure how much the water heats up from this known amount of heat that we're going to be putting into it. Exactly how circuits work and what voltages and resistors are and that sort of stuff will be covered later in the course after the midterm. Right now, we're just going to take this and use it and go with it. So find the resistors labeled 10, the wires, and the battery. And in the meantime, you should also get another cold water sample together. Now, The first thing to do here is take the screw caps off the battery. They're useful and we'll use them later on, but right now we don't need them, so we'll just put those out of the way. And you can hook up the red lead to one post on the battery. It doesn't matter which post you do in this experiment. It will work either way. Hook up the red lead, take the other end of the red lead. Don't hook up the black lead yet because things are going to get very hot when that thing gets hooked up. And then you attach the other end of the red lead to one leg of the 10 ohm resistor. Clip it on there, kind of pointing like that so it can drop down into the water. Once this thing gets attached, it will get very hot very quickly unless it's in the water. So just to check it, I'm going to hook up the other half, the black lead, hook up the wire to the resistor, and then put my fingers on the resistor and just barely touch it to here. Again, this thing is going to get pretty hot very fast as soon as I connect this. So all I'm doing is checking to see if my battery is live and the resistor is okay, and I am not going to leave it hooked up for long at all. So tap it. Yep, oh, that's getting hot. No question of that. Everything is working. Now we're going to put it in the water. So we take our water sample. The black lead is disconnected. The circuit is broken. The resistor is no longer hot. Put the resistor in the water. Put the cap on the water sample with the thermometer in place. Make sure the thermometer is turned on. And then hook that up. And right now, this resistor is sitting in the water. It's warming it up. It's putting in a known amount of heat into the water. The water is getting hotter. And if we sit here and watch the thermometer for a while, it does start increasing. If we left that in there all day, it would theoretically eventually start boiling. Frankly, I think the battery gives out before you do that, but it can get fairly hot. And just watching the thermometer, it's already gone up 1/10 of a degree since I started. In your lab manual, you will find formulas for how much heat is being injected into this system and how to turn that expression for power into temperature raises. So that's the third experiment. Okay.